Okay, so before we start, let's just go over some basics like what is a number line and yeah, those kind of things. Okay. Oh, what happened? This is not working.
Ma'am, what happened?
My
I
whiteboard
didn't hear
isn't
you.
working. Okay.
Oh,
Not to worry, I opened a new one. Let's, yeah, okay. My screen is visible, right?
yeah, it's visible.
Okay. ठीक है. So this is how a number line, or this is what a number line looks like, right? There is 0, and there are positive numbers and there are negative numbers, right? Something like this. Correct? So this is what is called the number line. Something you might have done in previous classes as well, just like a recap. In this chapter, you'll be making use of the number line quite often. So yeah, just some basics I wanted to brush up. Okay, so this line which has the set of all positive and negative numbers, right? So this would extend up to minus infinity, and on the right side it would extend up to plus infinity, right? So this whole line is called a number line. Okay, now coming to some other concepts which you need to know. Okay, suppose there are these numbers like 1, 2, 3, 4, 5, and so on. Okay, do you know what these numbers are called? Like there is a name for them?
Whole numbers?
No, try again.
Natural numbers.
Yes, natural numbers. So the numbers from 1, you can take note of this, okay? This is very important. You must know these basics, because once you know this basic, the dealing with everything else in the chapter becomes easy. Okay, so numbers which start from 1, so all the positive numbers from 1 to infinity are what are called as natural numbers. Okay, now coming to, if I include 0 in this set, okay, 0 and all the numbers, then what are they called?
Whole numbers.
Whole numbers. Yes, correct. Okay, now if I go one more step ahead and I include all the negative numbers, what are they called? Minus,
Integers.
and so on. Yes, correct, integers, right? So this whole thing will be called as integers. Okay, at this point maybe I should also include the notations, right? Natural numbers are denoted by capital N. Whole numbers are denoted by, does anybody know?
Hear you.
Sorry, I didn't hear you. So I am, what did you say?
W.
W. Okay, and integers?
Hi.
Okay, if integers is R, then real numbers would be
No, ma'am, not R. I said I.
I. Okay, 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 ठीक है. And then there is, so these are all the whole numbers, or what you could say is the, I don't know how to explain it without using these terms. Okay, let me try. So Apart from this, there are some more numbers which are left out, right? So these are not the only numbers which we deal with, right? What happens to numbers like 2 by 3, or let's say something like 4 by 7, or something like 1 by 9, right? These numbers also will have a place here, right, in this whole system. So these numbers are what would be called
Fractions.
Rational numbers.
rational numbers. Yeah, right. Okay. So you are telling me, ठीक है, rational numbers. Okay, before that, they would also be called real numbers, right? For going into rational and irrational, for checking that, you would be checking whether you would be seeing the decimal expansions, isn't it? So when you include all these fractions, etc., into this set, it is what is known as real numbers, the whole set. Okay, so this is real numbers. We'll come to rational and irrational numbers in a bit, because how do you distinguish those two is based on a different criteria, right? Okay, but yeah, they both also would fall under real numbers itself. Okay, yeah. So if you want, you can take a note of this thing I've drawn on the board. If you have, let's say, color pens or something, you can write this also for you to remember, right? Majority mistake happens in whole and natural numbers because you forget which has zero and which does not have zero, right? So you can remember it like whole as a has a O in it, right? So O would be with the zero. So whole would have zero and natural numbers, right? You can remember it like that. Okay. Okay, let me quickly take you through the theory part. Yeah, in your textbook, they have given the explanation for all this very nicely, but it's a little bit long, right? In the introduction part, they have explained whatever I just explained uh, nicely, but it's a little story format. So if you can read, you should read this. This is nice. Okay. Yeah. So we finished. N would be the natural numbers, right? Okay. And whole numbers is denoted by W. Okay. Next we have all integers. So integers are denoted by Z, and they've also told you how Z came into picture, right? Why not I is because I has other notation, or other meaning in math, where I is actually used to represent imaginary numbers. Okay, so that's why they didn't take up I, they took up Z. And how did Z come into picture? They have written it here. It comes from the German word Zahlen. I am not sure how to pronounce it, which means to count, right? Okay, so integers is Z, and then you have, yeah, then you have rational and irrational. We'll come to this part, right? I will come to this part. Oh, they haven't told you anything about real numbers. ठीक है. Okay. So all the numbers together would form, yeah, here it is, irrational numbers. Yep. So this is what I wanted to talk about. This is the real numbers, right? The collection of all rational and irrational numbers make up what we call the real numbers, which is denoted by R. Okay. So a real number is either rational or irrational. Okay. And it is, so every real number is represented by a unique point on the number line. Okay, which means all these numbers which we spoke about, which would be, right? All these numbers which we spoke about, all of them can be represented on the number line, is what they are trying to say, right? Because real numbers is the whole set or the whole collection of all these different types of numbers. Okay. Oh, I did not write it here. I thought I wrote it. Whole numbers is W, integers is Z, this is R. Okay, okay. Have you written this down?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes. Okay.
Yes, ma'am.
ठीक है. Okay. Okay. Yeah, make sure you've instead of writing sentences like definition of natural number, definition of whole numbers, etc. Because in maths nobody asks you definitions; they directly ask you using examples, right? So just create a way or draw it or make some way whichever you are comfortable with, just to remember that which is which. That's all. Okay. ठीक है. Let's see if this works now. Oh. Okay, so now we come to what are called as rational and irrational numbers. Okay, rational and let me write it here, irrational numbers. Okay, so real numbers, so there would be something like this. Let me, yeah, there would be real numbers here. Oh, which is bifurcated into rational and irrational numbers. Okay. Does anybody know what rational numbers are? You can try.
Fractions.
Okay, fractions. ठीक है. What kind of fractions? Are all fractions rational numbers?
Equivalent
Ma'am,
fraction?
Equivalent fraction. Okay, what do you mean by equivalent fraction? Do you know? What is the meaning of equivalent fractions? Okay, I think you might not be aware. Let me help you with this. Oh, somebody wants to answer?
So equivalent fraction is basically two fractions which are just, multiplied. Like kind of like 1 is to 2 is like, is equal to 2 is to 4.
Yes, correct, correct. You are right. So equivalent fractions are nothing but something which are one and the same, or they are can be reduced to the same value. Like you gave the example 1 by 2 and 2 by 4. This also comes to 1 by 2. You could also take the example 4 by 8, right? You could take the example of 3 by 6, or let's say 7 by 14, right? So all these fractions, they eventually would come down just to 1 by 2. So these are what are called as equivalent fractions. Okay, so this would be a type of fraction. Again, this is not uh, like the correct definition of rational numbers. Yeah, some of these fractions might be rational, some might not be. Okay, yes, ma'am, tell me.
Ma'am, today like we were learning number systems. So teacher said that it is P by Q, where Q isn't equals to 0.
Correct, awesome. Oh, you're doing this in school right now as well. Good, good.
Yeah.
And our class hasn't started it yet.
Okay. Okay, not to worry, we're doing it anyways here, na? Okay, yes, so Swayam is right. So basically, rational numbers are nothing but they are fractions which can be represented in the form of P by Q, where Q is not equal to 0. Okay, can you tell me why Q is not equal to 0?
Ma'am, if
Mom,
anything divided by 0, then the answer, like it's not possible.
Correct, yes.
the
Ma'am, it's
answer is not
undefined.
defined.
Yeah,
Yes,
it's
the
undefined.
answer is not defined, it's undefined. Very good, yes, correct. So if you try to divide anything by 0, it becomes undefined, or basically we cannot perform the operation, right? So that would become a different type of a number itself. it won't be called as a rational number, right? Okay, that is why this important condition is there, which is that the denominator should not be 0. Okay, ठीक है. Yes, this is the basic definition of rational numbers. Okay, you can note this down. Fractions which can be written in the form of p by q. Okay. Now can you give me some example of rational numbers?
4/5.
Okay. Right. What about something if I write something like 0.125? Is this rational?
If we write it as
Yes, ma'am.
125 upon 1000,
Yes, correct. So this can also be written as 125 upon 1000, right? Which makes it in the form of p by q, isn't it? Which means this is also a rational number. Okay. 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 Have you noted this down?
yes, ma'am.
ठीक है.
No, I'm noting it.
हाँ, okay, okay. I'll wait. I'll wait. So this part or this, let me just say, I mean, tell you this part here itself. So this is called a fraction, right? This is basically a fraction, and this notation is what is called the decimal expansion. Okay, you might see this word frequently in this chapter, which is decimal expansion, right? Okay,
I'm done.
done. ठीक है. Okay, now before we go on to irrational numbers, there is some things or there are a few things which I would like to discuss before we go on to irrational. Okay, there are some terminologies you must know for that. Okay, let's take an example of, let's say, 1 by 2. Okay, and let us try to find the decimal expansion of this. Okay, so 2, I'll put a point here and I will put 5 and I get the remainder 0. Basically r is 0, right? So this is 0.5. Okay, let's take some other example of give me 1 second, which number should I take? uh, okay, very interesting. I found one number. Okay, we do 4 by 9, right? Okay, so 9 and there is 4. Okay, so first I'll put a point. Right, I hope, I mean, you're familiar with this, right? What I'm doing, I'm just doing long division, that's all. I mean, division.
Yes, ma'am.
Okay, so I will put, yeah, since I put a point, I can put a 0. So 9, what's our, can be written here? 9?
4, no, yeah, 9 fours are 36.
Correct, yeah. So 36, again I get remainder 4. Again, I will put a 0, right? Again, I will put a 4, 36. Again, I
Ma'am,
get
it's a
remainder 4.
recurring.
Yes, correct. So
It's a
basically,
recurring decimal.
awesome. Yes. So good, you're listening, you're paying attention in school as well. That's good. Right?
Yes, ma'am.
Okay. Yeah. So if you notice, yeah, like Swayam told us, there is this word called recurring, which, yes, if you are not aware, we will discuss it in 2 minutes.
I
One
guess
more.
we did it like in one of the chapters.
In one of the
Like
Yeah,
we
I
chapters.
only
also remember. I also remember. We are
I
done.
guess it was in polynomials. Yeah.
Oh, no, I don't think you have concept of recurring digits or decimals in anything other than number system. At least in ninth,
I
no.
don't know, but yeah, we
But I
have
think we
done.
did it.
Yes,
Yeah,
ma'am. We
yeah.
did in polynomials.
Oh, is it? Or maybe because you started polynomials directly, your teacher might have done
No,
some
ma'am.
part
Like
of.
you only discussed it.
Yes,
I
ma'am.
discussed it.
Yes,
Oh,
ma'am.
I don't
Either
remember.
you or Lastya ma'am, I forgot.
Yeah,
Yes,
must
it
be
was
last year,
either you
ma'am.
or because
Could be possible.
we directly started with this thing with polynomials. So yeah, I don't remember who it was, but you said that we could do a quick recap of number systems and then start with polynomials. So then we did it there.
Ah, yes, yes, I understood. Yeah, it must have been Lasya ma'am. She was taking the class. Yes, yes, and the fact that she might have discussed is actually you need to know number system before going to polynomials, right? That's the correct order of going to the next chapter because number system and polynomials they both form a cluster. Like they are questions are asked based on both the chapters combined, right? Okay. Okay, not to worry. We'll just discuss all this again once more because this is the whole crux of the chapter, right? Okay. Okay. So yeah, if you continue this decimal or if you continue this division, you will keep getting 0.44444. Okay. Yeah. Till infinity, like till you get tired, you can keep doing this. This is not going to change, right? Okay. So this is one. Now I'm going to take example of another kind of number. Okay, let's say 1 by 7. 1 by 7 is supposed to be a very famous number. Okay, I'll tell you why. Okay, 7 and 1. Oh, just 1 second.
I don't know if it's just me, but ma'am, your voice is cutting, breaking a
Oh,
lot.
is my
No, ma'am,
voice?
it isn't breaking for me.
Maybe it's my internet issue.
Maybe you could just rejoin. You can do that.
Yes, ma'am, I'll rejoin.
Okay. Okay, so till then we'll just do this division, right? 7 ones are 7, you get a remainder 3, 30. 7 fours are 28, you get remainder 2. Again 0, you put 7 twos are 14. Uh, you get remainder 6, 60, 7 eights are 56. The reason why I'm doing this process, even though it's long, is because it will end. Okay, these are three different examples, which is why I'm just doing the whole procedure. Okay, I get 40, and then we have 7 fives, right? 35. 5077s are 49. You get 1, and then again, I will get 10 here. Oh, is my screen visible? Huh. Again I get 10 here, right? Which means again I will be starting with 1, isn't it? Okay, so the decimal expansion of 1 by 7 comes out to be something like 1428571, right? And then all these numbers in the same sequence, or basically it stops at 7, and then all these numbers are repeated again, right?
Ma'am, 7 is very interesting number because there are many tricks and all these things patterns and tricks and all
Yes, yes,
with
there are
it.
a lot of patterns and tricks. Yes, and the reason why I was saying this number is very interesting is because if you notice, like suppose you want to find, let's say, the value of 2 by 7, right? So, very interesting is you just pick up the second highest digit in this entire row. So, just look at this part, which I am putting it in a green box. Okay? Tell me the second highest number here. So, start from 1. So, 1 would be the lowest number, right? So after 1 you can see which number.
Two. Sorry, four.
2, you were right, 2,
Okay.
right? So if I say 2 by 7, I will pick up the second second number, or the second lowest number, and I just copy the entire decimal expansion from here, so it would become nothing but 0.2857, and since it's recurring, 1 4, right? Can you try for 3 by 7?
Ma'am, 5, 7, 1, 4, 2, 8.
Try again, try again. Is there any number lesser than 5?
4.
Ah,
4, oh, 4,
4, 2, 5, 7, and 1, 4. Repeat.
right? 4 by
Ma'am,
7?
I didn't get it. How did you do it?
Oh, you didn't get it? Okay, I'll explain again. Okay. Okay, so you understood till here, right? That 7, so this entire thing repeats after this pattern would repeat again. So it would become nothing but 1, 4, 2, 8, 5, 7. Then again 1, 4, 2, 8, 5, 7. Then again 1, 4, 2, 8,
No, ma'am, like I
5, 7.
understood that, but like 2 by 7 and all, like how do
Okay,
you get for 2 by 7?
how do you get? Okay, so the trick is basically you look at, you just arrange all these numbers in ascending order, right? Let's do one more step. So in ascending order, it would be there is 1, there is 2, then there is 4, then there is 5, then there is 7, and then there is 8, right? 1, 2, 3, 4, 5, 6. Okay. Why are there only 6 numbers? Is because if you do 7 by 7, you will get 1, right? So there should be only 6 numbers. If you see a seventh number, which means you did some mistake while dividing. Okay. So you arrange them in ascending order. Now 1 by 7 you already found out, you already know this is the value. So for 2 by 7 you pick up the second number in this row, which is 2. So now 2 पे से whatever the whole pattern is, wherever 2 is, you start looking at the pattern from there. So it will become this whole thing repeated. So basically starts as 2, 8, 5, 7, 1. Right? Same thing for 3 by 7, you look at the third number, which would be 4. So now go back here. So 4, 2, 8, 5, 7 would be your next thing. Right? Similarly for 4 by 7, there would be 5 is the next number. So 5, 7, 1, 4, 2, 8. Okay. So this is the trick. This is only applicable for fractions or for 1 by 7. For no other fraction is this applicable. Right? That's why it's an interesting fraction. Did you get it now?
Yes, ma'am.
Yes. Okay. Well, don't worry. This is just something I just wanted to show you, like because it's an interesting number. I just wanted to show you why it was interesting, right? Don't worry. They don't ask you any questions about this. Okay. This is just a trick for you. So you maybe at home you can try dividing 2 by 7 like I did for 1 by 7, right? Try doing for 2 by 7 and you will see you will get this exact same pattern like this, right? Okay. Okay, I'm erasing all this part because this is not required right now. Oh. Okay, so if you notice, we have three different kind of patterns here, right? One where, let me write in black. One where it is just zero point 0.5, right? One where you see one digit being repeating all the time, right? And the third pattern is this where a set of digits is being repeating or is being repeated, right? So this kind of decimal expansion, which is nothing but our first example, let me number them, right? So our first example where you have no repeating digits and where it ends is called what is known as a terminating decimal expansion, right? Or you can also add the word non-repeating or non-recurring in front of it. Just 1 second. 1 second. Okay, yeah, I'm back. Yeah. So this is what is called as a terminating or non-recurring. Non-recurring, recurring basically means something which is repeating, right? Okay, this is what it means. And terminating basically, terminate means finishes, right? That's what the word means. Or it ends, right? That's what it means. So terminating would be that this decimal expansion ends at some point. Okay, that's why it's called terminating, or you can also call it non-recurring terminating. Okay, now if you see here, this one repeats. Okay, so this would be recurring. Does this decimal expansion end? Can anybody tell me, does this decimal
Can
expansion
you
end?
repeat? Oh,
Ma'am,
No.
ma'am.
no, ma'am.
No, ma'am.
No. So
It
what
does
will I
not
call
end
it?
termination. Non-terminating.
Yes, awesome. Right? So this is recurring, non-terminating. Okay. Similarly, this is the same example, like there are different examples of the same thing, where in this case only one digit can be repeating, whereas in this case multiple digits can be recurring or repeating, right? So this can also be written like this with a bar on top, okay? So which means 4 is repeated. And in this case, this can be written as 1, 4, 2, 8, 5, 7. And I'll put a bar on all these numbers because all of them are repeated, right, in the same order. Okay. So both 2 and 3 are examples of recurring non-terminating decimals. Okay. Okay. Have you taken this down? Note it down. Okay.
One second.
Okay, I'll wait. So all the three examples which are there on the board, right? They are all examples of rational numbers, because I'll tell you, because they are basically they are recurring or they are terminating, right? Okay, done. Have you taken it down?
Yeah, ma'am.
Yeah. Okay. What
Ma'am,
about the
just I'm
others?
just writing the third part. Third.
Okay, okay. I'll wait.
Just 1 minute. I
Yes.
haven't like.
So again, these terminologies which are written in black, right? All these words are important because in questions they will ask you something like this: that is this number recurring, or is this expansion terminating, right? So you need to know what these words mean in order to be able to answer the question.
Oh,
Okay, done.
Yes, ma'am.
Okay, ठीक है, I'm clearing now. Okay, so now we come to one more set of numbers. So let me just draw the bifurcation again. This is real numbers, right? And then we have rational numbers.
Rational and irrational, right?
Yes, correct. Yes, irrational. Okay, rational we define as p by q, q not equal to 0, right? Okay, ठीक है. And now we come to irrational part. So irrational numbers are these numbers which are non-recurring and non-terminating. Okay, So what does this mean is basically there is one entire string of numbers. So I can take any example, okay, any random example I can take, which means the number could be something like 1, 4, 3, 2, 5, 7, 8, 6, 1, 3, 2, 4, 8, 5, 7, right? Oh, let me not put 5 and 7 together. Okay. 5, 3. Okay. So this number, and I can keep extending this. If you notice, there is no repetition, right? There is no pattern which you can see here. It's just a string of random numbers together and which don't end. Okay? These are what are called as irrational numbers. So a classic number which is an irrational number which you are very familiar with is pi, right? Pi is irrational. All these square roots are irrational. Root 3, root 2, root 5, root 7, right? Square roots of prime numbers. These are all irrational numbers. Okay? Just as some examples. Okay. Done. Have you taken this down?
No, ma'am, 1 second.
Okay. So pi actually, if you maybe you might not have used it till now, but in mathematics or when you do geometry or any problem where you need to use pi, usually for calculating area, right? You use it in geometry for calculating area. That time you take the value of pi as 3.14, right? Usually the standard is 3.14, or you also take it as 22/7. ठीक है, but actually this is just an approximate value of pi. Okay, pi actually has a lot of digits, which even recently, even using all this advanced computing techniques and all, they were only able to find the first trillion digits. Okay, so trillion is a very very big number, and they were able to find only the first trillion digit, which means they are estimating a lot more digits after that. Okay, some people, I think, even there is some kind of competition, or people usually try to memorize the digits of pi because it's a very complicated number, right?
Ma'am, but what if like it is a recurring like this thing, recurring number?
Yes, it is not a recurring number, so it is also a string of numbers like this. Okay, something like this which never ends, and there is no pattern. Okay.
Okay, ma'am.
But for
So,
calculation
ma'am,
purposes, tell me.
no, you go on. I'll just.
So for calculation purposes, taking that entire number is very difficult, right? Especially when we don't even know the complete number. So we have approximated it to this. Okay, let me write it here. It is approximated to this value. Okay. Because maybe when you do geometry, this might be the first question which pops up in your head, that array, when we did number system, ma'am told us that pi is irrational. Then how are we doing? We are taking it as fixed number, and how are we calculating, right? So this is the reason why it is still irrational, but just for easing calculation or making our calculation easier, we approximated it to this or this. Both of them are correct, and that's why we use it like this. Okay. Don't worry. I mean, I think in 10th standard you have this chapter again. It's called real numbers, and a little bit extra on all these parts you do now, and a detailed explanation or a detailed reason why pi is irrational would be taught to you in next grade, right? The whole explanation is there, that why is it irrational and yet we are approximating it. Okay. This is just for your knowledge. So you should not be confused that, oh, this teacher is saying rational, one teacher is saying it's 3.14, the other is saying it's never ending, which is correct, right? Okay. Okay, done. Shall we go ahead?
Yes, ma'am.
Yes. Okay, so this is all about the theory for rational irrational numbers. Usually the type of questions you get is, let me just show it to you. Uh, this is right. Yeah, so this is the kind of questions you'll usually get. Just a second. These kind of questions. This one, find five rational numbers, right? Or find decimal expansions of these numbers. Or show that ka part we are still not gone. I will come to that. This example, right? All these are from this part which we just did. Okay? So let's take one example and I'll show you how to actually solve it. Okay, let's take this one, 1.1.2. Okay, I'll show you how to solve these kind of questions. So our question is find five rational numbers between 1 and 2. Okay, so okay, I think my board is finally working now. Just 1 second.
I guess like we convert it into fractions and then write the numbers between them.
Uh, but how will you convert 1 and 2 into fractions?
Ma'am, like multiply or something. Ma'am, I don't exactly remember it. We had it in seventh.
Ma'am, will we take 1 as the denominator?
No, if you take 1 as the denominator, it becomes the same number, right? So anything divided by 1 is the number itself, right? 2, something like that.
Ma'am, like for example, if we multiply both the numbers by 10, so it will be 10 by 10 and 20 by 10. So you can write five numbers between them. So that is same as writing like five numbers between 1 and 2.
Okay, okay. So that is what you are saying. Yeah, that can be considered as one method. Yeah, but the more commonly used method is what I'll just quickly show you. I is still not working, or is it working? Working. Okay. Okay, so what do you do? First thing is, let me just close this. This is really not working. Okay. 1.1.2, rational numbers between 1 and 2. Okay, so the first thing you usually do is you would take the average of these two numbers. What is average? Can anybody tell me?
Ma'am, is it same as like this thing, LCM or something?
My
Uh,
average,
Tell me, Aryan.
my average is an approximate value of a certain number of numbers.
Approximate value, not approximate, it is basically the middle value, right? Okay, so
Yes,
when you
ma'am.
say
That's like
average, right? Uh, if I say tell me the average of 5 and 6, right? So what I would do is,
5.5.
yes, 5 plus 6
5.5.
divided by 2. Okay, because there are two numbers, that's how 2 came in the denominator, right? And if you do this, you would get 5.5. Yeah, you're right. And for example, if I give you three numbers, let's say I tell you 5, 7 and 11, right? Find the middle value of these three numbers. Then I would do 5 plus 7 plus 11, and because there are three numbers this time, I would divide by
23 upon 3.
yes, correct. So if you solve it, you would get some value, right? Yeah, 23 upon 3, and dividing further, you would get the exact middle value of these three numbers. Okay, so this is how basically average is calculated. Again, you will do this in detail in statistics chapter, right? Okay, but for now, you just need to know that what is average, right? Because this method we usually use average to get the numbers. Okay, so I'm going to take average of 1 and 2, which means I'm going to add these two and make it 3 by 2.
1.5.
right? Now I got one number, right? This is one number. Now to get the second number, what I'll do is I'll take average of 1 and 3 by 2, and I'll take the average of 3 by 2 and 2. Okay. When I do this, I'll get my second number. When I do this, I'll get my third number. Right? Now you can choose any one. Suppose if you're taking this what will you get? It would be nothing but 2 plus 3 by 2 by 2. This would be nothing but 5. Right? Oh, I made a mistake somewhere. Why won't it erase? Yeah, and this would be nothing but again the same thing. This will be 4 plus 3 by 4, which is nothing but 7 by 4. So we got 3 numbers till now. Okay? And to get the remaining 2, you can either take up any one of these and do the same thing. So if I take suppose 5 by 4, then again you take 1 plus 5 by 4 by 2, and you take the average of 5 by 4 plus 2 by 2. So you get your fifth number. So what have I done is basically I have just taken averages. I have found a middle number, and then again I have taken the average with the extreme number. So these are the extremes, right? We need to find numbers in between these two. So if you keep taking that, you will keep getting middle values, and like that you can calculate as many values they tell you to do. Okay. Okay. So I just wrote it till here. You can complete it. Okay. You can leave it as fraction, or you can convert to decimal if you're familiar with decimals, nothing like it. So this would be nothing but 4 plus 5, 9 by 8, right? And this would be nothing but 2, 4 into 2, 8, 8 plus 5, 13, 13 by 8, right? So your final 5 numbers would be, I'm writing it here, 3 by 2, 5 by 4, 7 by 4, 9 by 8, and 13 by 8.
Ma'am,
Right? Yeah, tell me.
ma'am, can we do the method which Sujal said? Can
Yeah,
we
you
use
can
that?
do that also. But for that, you need to be very familiar with fractions. Like, the only thing you need to note here is that your fraction should not exceed uh, 2, right? So this all value should come between 1 and 2. If you are familiar with that, you can do that as well. Not an issue.
Ma'am, because in seventh and all, the teacher said that this is like the one I told is an easier way to do it. So she said that you can use this as well.
Yes, yes, yes. Definitely,
Yeah,
it is an
ma'am.
accepted method. The only thing is when you do that, right, there are a little bit of chances of going wrong. Whereas this is like a foolproof method. So both are correct. Absolutely, you
Okay,
can
ma'am.
use any one which you are comfortable with. Just at the end, just check it once, right? Just check that whether all these decimal expansions of all these fractions or the fractions you are getting should come between 1 and 2 itself. It should not exceed the range, right? Okay. Okay, let's take one more example so that I'm sure that you understood this. Okay, which one shall we take? Okay, let's take 3 and 4. Let's take 1.1.20, this one. Okay, find 6 rational numbers between 3 and 4. I want all of you to solve it and send your answer in the chat box.
Can you show the solution for the last question once again?
Okay, I think I erased it. Let me see if it is there. Here. So this is the final answer, right? Here at the bottom. On the
Yes, ma'am. Done. Thank you, ma'am.
okay. Okay. Sujal, you can tell me all the numbers together itself. I'll wait. Okay. Don't send it one by one.
Okay, ma'am.
Okay. Yeah. So we are doing question. This one. Hmm. Find 6 rational numbers between 3 and 4.
No, I sent it.
Okay. Okay. Let me just check 1 minute. Yeah, very smart. Sujal is Sujal is very smart. Yes. Good job. Did you calculate or did you just take the numbers?
No, ma'am, I just did like for like average and then I just took numbers.
Good job. Good job. Very good. Okay. Okay. Once everybody is done, I'll tell you what Sujal did, which is the absolute shortcut for these kind of questions. Okay. Just give me 1 second. I'm just checking Swayam's answers.
Ma'am, it can't go wrong because it's the simplest thing I can do.
Yeah, it looks okay. Yes. Okay, so you did the method which
Yeah,
you were
ma'am.
telling, right? Okay.
And no, ma'am. Actually, what I did was, I took pi. Then it's like value 3.14. So I did it that way.
Oh, that is smart. Good, good, good. Okay. Yeah, Suhani has also given the same fractions. Yes, correct, Suhani. Your answers are correct. I am waiting for answers from. Oh, Samruddhi has also sent. Awesome. Yes, Samruddhi. All your answers are correct. So I think only Aryan is left, right? Aryan and Ashka.
Yes, ma'am.
Yes, ma'am. Just a minute.
Yes, yes. Okay. Right, so this question which we did was the simplest type of question you can get in this chapter, right? Like as you keep going ahead, the level of difficulty will keep increasing, where in the end you have exponents and rationalization, right? So mostly, if questions come from this chapter, it's always direct 3 marker or 4 marker, or now it's become 5 marks. So 5 marker question where they'll give you one question for rationalization, right? 1, 2, 3, 4. What happened? What happened to the other two, Aryan?
I've sent.
You sent 4. There are 6 numbers. 2 more are required. Okay. And Ashka, what happened? You solved, didn't solve? Hmm.
Yes, ma'am. I'm just finding the last one. I'm done with the 5 of them.
Okay. Okay. So till the time she completes, let me just quickly tell you. So the simplest way of doing this is what Sujal did, right? So if you have 3 and 4, you will directly take up any six decimal values between 3 and 4, right? It can be 3.1, 3.2, 3.3, 3.4, 3.5, and 3.6, right? This is the easiest way to solve this question, right? You can use this for that question we did for 1 and 2 also. 1.1, 1.2, 1.3, 1.4, right? Simple, right? The average method or the method that I explained would be helpful when you encounter questions like this, which is where you've been already given a fraction like 3 by 4 and 4 by 5. That time coming up with decimal expansion becomes little tricky. Of course, you can evaluate 3 by 4 as decimal, evaluate 4 by 5 as decimal, and then pick up any random values between the two. That is also valid.
But then, ma'am, the one you showed before, this one, the decimal shortcut one,
Hmm.
this one would work if we have like, just we need to give the answer. We don't really have to show what we did. Like right now, we're just telling you our answer, so it works. But when they tell us to show the working, it won't work, right?
Uh, okay, but yeah, mostly these kind of questions they know that you might be aware of the shortcut, so they won't really ask you to show you the word key, right? Usually
Okay.
not, because these are like simple questions which are asked only when you're new to the chapter. Like as you move towards your final exam or as you do this chapter 2 3 times, you'll notice that they don't even ask you these questions. So these are like introductory simple questions, right? Usually they don't ask how you solved it. You can use any method you like. Okay, Ashka, yes, I've got your answer. It seems to be okay, but still I will check it once. Okay, I'll check it in a bit and I'll tell you. Okay. Yeah, so these are some of the shortcuts, right? One shortcut being which you all mentioned about finding equivalent fractions. You can use that. If you want, you can use this. You want, you can use the average method. So now you have 3 4 methods in front of you. You can use whichever you're comfortable or you find that okay, I'm this is easy, or I'm able to solve using this. So just go ahead and use that. Okay, okay. What I'll do is after class I will be giving homework definitely, because this chapter you need a lot of practice. Okay, so I'll include these questions also again so that you are very thorough with your practice. Okay, so now we are done with that. We shall go on to another concept, which is one second. Okay, so now you know three things, right? You know how to find decimal expansion for any fraction, right? How would you do this? Oh, you checked your answer. Okay, Ashka, very good, great. Okay.
Ma'am, like, what exactly what we have to do?
Okay, so for example, I give you a fraction, let's say 1 by 2, and I ask you to convert it to decimal. What would you do?
Ma'am, we would like by any means like we could multiply the denominator and make it into a multiple of 10, and then we could just I guess like for example this one we take like we multiply by 5 by 10, and then so that in fractions will be 0.5.
Okay, that is accepted. Okay, so you're saying this way. Okay, yeah, this is okay. You could use this way, or the other way would be simply by division, right? You just divide,
Yes, ma'am.
है ना? Which we saw using 3 examples. Okay, so basically when you are asked to find the decimal expansion for any fraction, all you need to do is divide. Okay, this will give you your answer. Yeah, if you are comfortable with this, you can do this also. There is nothing wrong in it. Okay, then next part, or yeah, Next thing which we discussed is how do we find rational numbers between two numbers, right? Okay, we discussed this. So this again you can take average method, you can take, we had three methods here, right? Direct, average and the equivalent fractions one. Okay, now we come to an interesting part, which is how do you find the fraction for decimal expansions, okay, which is nothing but the ulta of what you do in one. So for example, I give you some number like this. Let me take simple number. Suppose I give you 3.14 and I ask you express it in fraction. How would you do it?
Ma'am, 314 upon 100.
Very good. Yeah. Okay. Another example could be, let's say, 2.7. This would be
27 upon 10.
27 upon 10. Perfect. Yes. So if I'm giving you simple decimal expansions, right, something like this, which are non-recurring, you can do this easy method and you can maybe simplify it further, right, because this is definitely divisible by 2. You could simplify it and get some simple lowest fraction, right? Okay, now my question is, what would you do if I give you numbers like this? Like let's say 3.4, where 4 is recurring, right? Or maybe something like a number like this where it is maybe take the take the example of 1 by 7 itself, where I tell you this whole thing is repeating. How would you derive, or how would you go back and tell me that this is 1 by 7, right? So there is this interesting method we use to solve these kind of questions, which is what we are going to do now. Okay. Okay, let me clear all this. Let me take an example from the book itself. Uh, okay, let's take this one. Let's take both. I will take one after the other. So we'll do 1.1.7 first, and after that we would do 1.2.7. Okay? Or what I'll do is we'll do 1.1.7. I will give you these two as homework since we need to discuss a few more things as well, right? Let's just do one. Okay, so it is 0.3. Cool. Right, this is the number. So first thing you do is you express it in the form of a equation, or you just say let x be 0.3. Okay, and then what you do, you get rid of this recurring part by just multiplying it with the number of digits which are recurring, right? For example, your second equation would be nothing but 10x is equal to 3.33.
Ma'am, we did this.
You did this. When did you
Yes,
do
ma'am.
this? School में?
No, ma'am, in
Ma'am, Lakshma ma'am
class.
taught us.
Oh, she taught you. Okay. So you are aware on, are you familiar with how to do this?
Yes, ma'am.
Yes, ma'am.
It's a little confusing sometimes.
Okay. Okay. ठीक है. Okay. Okay. Not to worry. I'll quickly discuss it in case anybody doesn't remember, or you have any issue. Let's do it quickly. Okay. So you write the equation, or you write the question as it is. That is your first step. What you can do is you can write whatever I'm saying, or write it as steps, so that you don't mess up later. Okay, or you don't get confused. Okay, so first thing you do is you write it as a variable. If you take x, you can write x equal to zero point 0.3. You can take y, z, any variable you like. Okay. Next thing you do is you multiply with the number of digits which are recurring. So in this case, there's only one digit which is recurring, right? So it would be 10. Suppose if the question was let's say 0.23, both are recurring, then what would you multiply it with?
100.
100. Yes. So it will become 100x is equal to 23.33. So what you're trying to do is you're trying to remove this bar. So wherever or the number of digits on which this bar is there, you just multiply with that many zeros. Okay. So for example, if I say it is 3125, where 125 has a bar, so you will multiply it with 1000. Okay. So it will become nothing but yeah. Okay.
Ma'am,
3125 has a bar. 4 digits. Yeah, I missed 10. That's what I was trying to see. I did some error. Yeah, 4 digits. So it would be 10,000, right? And this would be nothing but 3125.31. Okay, something like that. So this is how the pattern goes. Right? This is where you get confused as to how much you're supposed to multiply. What happens after this is very easy. There's nothing much to do. Right? Now you just do 2 minus 1. That's all. Do 2 minus 1, which means you'll put 10x here equal to 3.33 and you put x here equal to 0.33, right? Why 33? 3 is recurring, right? So I just filled in the gaps. And you subtract. If I subtract, what will I get here? This will become 0, 0. This would become 3 and this would be 9x, right? Or x is nothing but 3 by 9, right? So this becomes 1 by 3, right? Got it? So just write the steps. So step 1 would be write this in terms of any variable x or make it a linear equation, right, or an equation. Second step is to just multiply with the number of digits under the bar, right? One digit, then with 10, that many zeros basically. There are two digits, so 100, 3, then 1000 and so on. Usually you'll stop at 1000, they don't go beyond that. Uh, what is Scribble? I'm not sure. What is Scribble?
Ma'am, it's an online game.
Okay.
It's really fun.
What is it? I mean, like, is it math related? Is it some?
Ma'am, yes, ma'am, we can customize the words.
Ma'am,
Ma'am, so like
yesterday,
a
Created with
person will be
Lovlit sir
given a word.
yesterday.
Okay, yeah, just tell me how do you do it? A person will be given a
Yes,
word.
ma'am. So a person will be given a word. He has to draw the word, but not tell it to anyone. And then, once he draws it, others have to guess it. Like what is it?
So there's a chat box option. You have to guess your words there, and if you get it right, you get points. Like if you guess it right before the time
And
gets
like you
over.
can customize it. Like so, yesterday
Yes,
Lohit sir
ma'am.
customized it to
Yeah.
like physics,
It was all
physics.
about
Physics
physics,
words.
like
So like
displacement and mass.
Oh, nice, nice,
Yes,
nice.
ma'am.
So
But
we
in this
can make it math related or science related. You can do
science
that.
related, acha, but science related we don't have anything right now. Now when maybe we do revision for tissue or something, maybe we can do. Maybe in this class,
Ma'am, maths.
math may what you want to
Maths is
guess.
okay. Like maths words, like any now we did recurring, so you can give 3.3, then bar on the topic and like tie. Like you can draw. Sorry,
Okay.
How are
you
you
have to
gonna
draw
do that?
everything,
Okay,
and
I
then you
think
have to
math would
guess
be very
maybe.
easy because yeah, you just give the number and
We
ठीक है,
can do
okay,
things
we
like
can.
line segment
Then,
or this angle, that angle types. You know?
ma'am,
Okay,
maybe normal words
Like
also.
related to geometry.
okay, okay. And who gives this word? Am I supposed to give it or you will choose a
You
word?
can add
Ma'am,
it.
if
Ma'am, you
you're
can
the
add it. The
host, you can
host.
customize the words on your own. Like you can enter the words,
ma'am, so in
and
the
it
start
will.
of the game, there is a box where you can like add there is a box where it says that add custom words. So you have to take it and then add the words that you want related to whatever you want. And then when the game starts, a person chosen by the game, randomly chosen by the game, gets three options. He has to choose either one of them and then he has to draw it, and then
Ma'am,
the
I have
others have to
pasted the
guess.
link of it. I pasted the link of it
Okay, you
And
in the
pasted the
chat.
others
link.
guess what he's trying to say.
Okay. Yeah, yeah, I understood what he's trying to say. I'm just okay. I might have to look at it to get the feel because I've not seen it. Okay, yeah, I don't mind. We can definitely play. Sure.
It's
Let's
very
play.
easy. Even I didn't know how to play that the first time we played it yesterday. You get a hang of it really
Yes,
easily. You
ma'am.
just
It's
draw
easy,
it.
ma'am. Very
Okay,
It's
okay.
easy.
So
like
I need
Damcharaj, but
to.
you need to draw.
So do I need to open it here and then you'll connect to it something like that, or how
No,
is
Yes,
it?
ma'am.
ma'am.
You
Like
just
there is
have
Yes,
an
to host
option.
a game.
Oh, I have to
You
Yes,
just
host.
there
have
is
to host.
Okay,
Yeah.
okay.
there is an option of like start private game, and then you have to click on it, and like in the bottom there is a link which you have to copy, and then you can send it anywhere, and like we just have to click on that link to join your game.
Okay, cool. ठीक है. Let's play. Let us finish just one more concept.
Yes,
Yeah,
ma'am.
and then we can play. ठीक है, I don't mind that. Okay, cool. So this, I mean, whatever I wrote regarding this, is this clear? And the steps, have you noted that down?
Yes, ma'am.
1, 2, 3. So this is step 1, this is step 2, and this would be step 3 where you're basically subtracting the two equations. So 10 minus x. So suppose if it was 100, it would basically you would be left with 99x, right? Or always your denominator would be in terms of 9, whereas if it's 1000, then it would be 999x. Okay. So based on the type of number it is, you will get something in this format itself. Okay. Okay. Okay, let us go back to the questions. Let me see what else is uh, there. Yeah. Okay, now we are left with yeah, a lot of things, but for now, okay, I can give you all this as homework. Number line. Okay, so we need to do number line, and what else do we need to do? Just give me 1 second. Yeah, I did this, right? Yeah, I did the division part, I did this part, I have to do. Yeah, so you don't have successive magnification. It was not there last year also. So this part of representing real numbers on the number line up to some decimal places, right? This kind of questions are not there. So successive magnification is omitted. Um, ठीक है, let me finish number line and this part, right? Both are the same, so let me just finish those together and then we can play the game. Then it would be just rationalizing and exponents, which sir can do tomorrow. ठीक है? Okay, cool. I know what we need to do. Let's do it. Okay. So now your next concept is how do you plot or how do you represent numbers on the number line? Okay. So for example, if I give you some number like let's say 3, right? 3 is easy. You just draw a line and you will mark it here and you'll say that 3 is being marked, right? Or maybe if I give you a number like say -2, right? So all these numbers are basically integers, are very easy to represent on the number line because they are these values or these numbers you've written itself, right? Now things get complicated when you get the following two cases, right? One is you get how to represent irrational numbers, right, on the number line. How do you know where they come, right? How would you denote them or how would you plot them on the number line? And the second thing would be how do you represent these numbers geometrically, right? Okay. So we'll just take up the first part, which is basically, let's write the heading. Again, this is not frequently asked because you have rationalization being the very important part of the chapter. But then again, if occasionally they feel like asking, it shouldn't be that you don't, right? How to, this is the heading, how to represent irrational numbers on the number line. ठीक है? So this part or this topic again involves use of what is called the Pythagoras theorem. So what is the Pythagoras theorem? Can anybody tell me?
Ma'am, like the addition of the squares of two sides should be equal to the third side.
Okay, okay, okay. Quite close.
So it's basically AB square plus BC square is equal to AC square.
Okay, okay. Again, close.
Ma'am,
Yes,
or
you've
like
given me
a
the
square plus
equation.
b square is
And
equal
base
to c
square
square.
plus height square is equal to the hypotenuse square.
Yes, yes. Correct, correct. Okay, okay. All of you
Ma'am, it's
have.
like basically base plus hypotenuse. No, I don't remember what do you call AB.
Height.
But yes, ma'am,
Base
base
plus
plus
height.
height is equal to hypotenuse.
Correct. Yes, yes, correct. Okay. So all of you are missing one important line, or the main focus before starting it would be in a right triangle. Isn't it? It's not applicable to all triangles. Is it applicable for all triangles?
No,
No,
ma'am.
No,
ma'am.
right? So that is very important. So this is applicable only in right angle triangles, right? Oh, okay. This just become a scribble. Right triangles or right angle triangles, where, like you said very correctly, the mathematical statement is nothing but CB square plus AB square is equal to AC square, right? Okay, so yes, we have Pythagoras again to thank for this, because he is the one who found out how do you plot these numbers on the number line. Okay, so for example, you take root 2 as your number. Okay, so what do? The steps here are very simple. First thing, you take a number or a perfect square which is close to this number. ठीक है? ठीक है? This would be your first step. Okay, so which perfect square is close to root 2, or which is close to 2? Leave, forget the root.
1, 1.
1, correct, right? Okay, so perfect squares are basically squares of numbers from 1 to 25, right? They are called the perfect squares. Like 1 is a perfect square, 4, then 9, then what is there after that? 4 ka 16, 25, 6 square 36, right? So on up to squares of 25. These all numbers are what are called as perfect squares. Okay. Okay, in case you are not aware, you can write this somewhere. Again, this is not asked, but most of the time the words used or something like that might involve something called a perfect square. So that time it should not be that you don't know what it is. Okay, I'll write it here. Squares of numbers from 1 to 25. Okay, these are all perfect squares. Okay, coming back to our thing. Okay, so what happens is you take that perfect square close to 2, and when you add those two, you will get basically, if you apply Pythagoras theorem on this, your hypotenuse will come out to be root 2, right? Isn't it? 1 plus 1 gives you 2, and if you apply Pythagoras theorem on this triangle, you get the hypotenuse as root 2. So this exact same thing is then represented on the number line. That's all. Right, where you have 1 2 3 4 etc. Okay, so what you will do is you will measure 1 centimeter, which is nothing but you start at 0, stop at 1, right? And then again you will plot 1 centimeter height here. Okay, both are 1 1, and now you join these lines. Okay, let's call this O, let's call this A, and let's call this B. So you join OB with a scale. Okay, this becomes root 2, which is the hypotenuse, but we still don't know where it falls on the number line. So now you will bring in your compass, you will place your tip at O. Okay, take the radius as OB. Okay, and draw an arc. So wherever that cuts the number line is what would be root 2. Okay, so this is just the basic thing. What you can do is, if you don't have your compass nearby, just get it and let's do it together. I'll show you step by step how to plot this thing. Okay. Okay.
Ma'am, so we take the radius as OB, and after we place the seal pointer at O, and we make an arc. So where the arc goes is the root of
Yes,
the.
correct. Yes, absolutely. Okay. Okay, this is just explanation part I wanted to explain. Let's draw it together. Okay, bring your compass, ruler, and pencil, and we'll start drawing together. So you mark the numbers at 1 centimeter distance. This distance should be 1 centimeter, 1 centimeter, right? You can stop at 4 or you can even stop at 3 here, but 4 to be just safe, just to show proper number line. Okay. Once you are done with this, you can draw a horizontal line of 1 centimeter here on one itself. Okay. Right? Okay. Tell me when you are done till here, then we'll go ahead.
Done now.
Okay. What about the others? Done?
Yes, ma'am, done.
Ma'am, 1 second, I'm doing.
Okay.
Yes, ma'am, done.
Done.
Yes, ma'am, done.
Done. What about Sujal and Aryan?
Ma'am, done.
Done,
I
done.
said done
Done.
earlier.
Okay. Okay. Oh, I missed it. Sorry. Okay. So now let me just name these points. Suppose this is O. You can call it anything. You can even call it A, B, C, whatever you like. Let's stick to O. Okay. And let us call this A. Okay. So this becomes the base of our triangle, right? And this is the height, which is OB. Now take your scale and join OB.
Yes, ma'am, done.
Done? Okay, now
Done.
get your compass and place the pointed end on O and take the radius as OB. So OB is equal to radius.
Ma'am, OB, right?
OB. Yes, hypotenuse. Let me write
Okay,
it
ma'am.
here. Hypotenuse. Your radius would be your hypotenuse. Okay. In case you've labeled it as anything else, just for clarification. Right? Okay. If you've taken your radius as that, now you place your compass at O. Right? So this is your compass. I'm sorry, I'm not having access to all this right now. Okay. And you draw an arc. Right? And that arc will cut your number line at some point, let's say X. Right? This point is basically root 2.
Ma'am, I didn't understand this. Can you repeat?
Yes. So you've till where did you do? You joined OB?
Yeah, after taking the radius of OB.
Yeah.
Yes,
So
ma'am.
keep your pointed end at O. Keep your pointed end at
Yeah,
O and
ma'am.
simply draw an arc on this pink line or your number line. Just wherever it will
Okay,
cut,
ma'am.
just cut it there. Yeah. Draw an arc there.
Ma'am, what about the triangle you had made? Like,
Oh, that was just a representation of the compass.
Oh,
Sorry. Sorry, did that confuse you? No, I just meant
okay.
that you need to keep your compass here, take this as the radius, and basically draw this arc, or just cut the number line. That's all.
Okay, mama.
Yeah,
Okay.
Then I was correct, mama. I
another.
thought you had to do
Yeah,
something.
that's
No, no,
what.
no. Sorry, sorry, sorry. My mistake. I shouldn't have done that. Yeah. This is all is the construction. That's it. So this point where you've cut the number line, right? That would be root 2. You can write it there below that this is root 2. Okay, done. Okay, we'll take up one more example because yeah, this method if you do once more you'll be more thorough, and the remaining I'll give you as homework. So today you're going to get a little extra homework, but yeah, it's required for practice. Okay. Okay, we'll take up root 3. So usually in the exam they ask you root 3. Root 3 is very famous, or very the most common question is root 3. Sometimes they ask root 5. Root 2 they rarely ask, because you need to draw root 2 to get the other numbers, so that they won't ask directly. Okay. Okay, everybody done? Shall we do the next one?
Yes, ma'am.
Yes. So in your textbook and even in the chapter notes, the explanation for this is given as to why this arc, when you cut here, it becomes root 2 itself. So if you are interested in the explanation, you can read it. I think it might be a little bit confusing, which is why I'm not explaining it at this stage. Right? But yeah, if you're interested as to how, or yeah, how did it work like that, you can go ahead and read. They've proved it for you that how this distance will now be root 2, or this point will now be root 2. Okay. Okay. Okay, if you are done, let us take one more example, which is we are going to take root 3 this time. Clear everything.
Yes, ma'am.
Okay, we'll take root 3. Okay, what is the closest square to root 3? Or 3, forget the root. Closest square to 3?
4.
Okay, 4.
Ma'am,
Okay,
how much will we take for one uh, unit?
for
The,
root
the
1.
number line. No, ma'am. This.
Oh, the distance you are saying when you plot number line like this.
Yes.
Usually you take 1 centimeter,
Okay, ma'am. For okay.
right? Because they are numbers like this, right? So usually the distance is 1 centimeter. Yeah. In these kind of problems, take it as 1 centimeter, because otherwise it will go haywire, right? Because your base needs to be 1, so take it as 1 itself. Otherwise, I would have said take anything, but yeah. For these kind of questions, make sure you are taking it as 1 centimeter. ठीक है. Okay. Coming back, yes. So the closest perfect square to, okay, yeah. Root 3 is 4. Okay, 4 can be written as 2 squared, correct? Oh, okay, okay, okay. My bad. For these kind of questions, you will not be able to take numbers where, yikes. Okay. Okay, so what happens if I take 4? I'll tell you why we can't take 4 is. How would you express 4 in terms of 3? You would have to write it as 4 minus 1, right? Okay, when you write it like this, how would you get root 3 as your hypotenuse? Right, because for Pythagoras theorem, it has to be always something plus something. Okay, so in this case, you will not be able to take numbers which are greater than the number itself. Okay, so if I say closest, always look for the value which is below the number. Yeah, like again in this case it would be 1. You got it right. It's only because Pythagoras theorem is this OAB is nothing but OA square plus AB square, right? OB square. Okay, so whatever relation you are getting should be in terms of plus or should be as a sum of two numbers itself. Okay, because your target here is whatever irrational number you are given to be represented on the number line, that should always come on your hypotenuse. Again, that reason is explained in the construction, which is explained with the proof and all that, but it's a little too complicated to make you understand right now, which is why I'm just skipping it. Okay. Yeah, it's not asked. You will never be asked to explain your construction here. For that, we have our construction chapter, right? Okay. But here, logic is the number should always come on your hypotenuse. The irrational number will always come on your hypotenuse. That's the basic logic, right? Okay. So 3 can also be written as 1 plus 2, right? Or this would be basically written as 1 square plus root 2 square, right? Or your triangle will look something like this would be root 2 units, this would be 1 unit, and this would be root 3, right? Okay, so when you plot this line, now this time when you plot root 3, you will need to plot root 2 first, right? Since I'm drawing the numbers a little bit far apart just for convenience or just to make you explain, right? Just to make you understand. Okay. Okay, so now what you do is first you complete the entire step for root 2 construction again. So now let me see if you remember or how well you understood. So first plot root 2 and tell me once it's done. Then I'll tell you what needs to be done ahead. Start Excel again. Restart it. To restart, sometimes it happens like that. When you restart, it starts working. Oh.
Ma'am, were you saying anything?
No, no,
Because I
no.
wasn't able to hear.
No, 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 no. I'm not saying anything.
Okay, ma'am.
Okay, once you're done with root 2, tell me. I will tell you the steps ahead, so I how to do it.
I'm done.
Done? Okay. What about the
Ma'am,
others?
done.
Done.
Ma'am, done.
Ma'am, done.
Done. Okay. 4 are done. Samriddhi and Aryan are left. Samriddhi and Aryan done?
Yes, ma'am.
Done, done.
Done? Okay. Awesome. So now that you have root 2 on your number line, now what you will do is you will take this as your base, which is nothing but my green line. Okay, because this distance is root 2 units from origin or from 0, right? That would be your base, and now you will draw a line of 1 centimeter here. It's nothing but this green line. Okay, this will again be 1 centimeter. Let's call this D, right? Now connect OD. Again take OD as the radius and cut an arc. Use the color. Right?
So we made D, it is also supposed to be 1 centimeter, right?
Yes, yes. D is also 1 centimeter. So it is basically this triangle up here. If you notice this one, this is what we are plotting now here. So base would be root 2 units. How do you get root 2? Is by doing the complete construction for root 2. So then take the base as that point, then height would be 1 centimeter, and then when you join it, that would be root 3. So OD
Ma'am,
becomes root 3.
done.
Done. Awesome. Yeah, it will look a little bit messy, but this construction, I mean, you cannot really scale up, so they leave it at messy level itself.
It's very messy.
Yeah. That's why they don't ask this also frequently. They don't like asking. I've not seen that many questions. Okay, what about the others? Done?
Yes, ma'am.
Ma'am, I just made a mistake. I'm doing it.
Yes, ma'am, done.
Ma'am,
Okay.
just a minute.
Okay, let's wait for 1 minute.
And yes, it's really messy. Like it's very
Yeah, it's messy, right? Okay. Okay, so
like
now we
it's
are just
to
tell me.
mark it. It's difficult to mark like the AOB after the whole construction. It looks like weird. Like it's overlapping.
Overlapping, yes, yes, yes. So in these constructions, you don't have to worry about the names and all. You don't have to label it. You just have to label root 2 and root 3 or whatever they've asked you to find, right? That is sufficient. The rest part, if
Yes,
you don't do,
ma'am,
is
done.
okay. Okay, done. I labeled it and I gave it names just for to explain that which distance you need to take or which what radius you need to take, right? Okay. Okay, now we just have one small part, which is the geometrical representation of irrational numbers, which is based on a similar logic, but that would look better. Okay. Again, that is not frequently asked, but you need to know what it is. So, yeah, let's finish that. Then we'll be done. Then tomorrow's class, you need to just do rationalization and exponents part, right?
Ex- Exponents is
Operations.
very hard for me.
Operations on rational numbers, rationalizing and exponents part. Okay, these three parts are pending. Okay, done. Shall we finish through the last topic for the day? Shall we do it? Okay, I think everybody's done. Okay, so you can take the heading as, or you can write the heading as geometric representation of irrational numbers. Okay, so whenever they ask you geometric representation, this is what you do. When they ask you plot on the number line, what we did previously is what you will do. Okay, okay, this is the heading. Let's take any example, whichever you want. Is there a question? Let me quickly see. Okay, there is one. Let me take that only. It's in level 2. Okay, so this usually there will be numbers which have decimal points in between, something like this, right? 9.3 is one question. So for number line, they will stop at whole numbers, or basically there would be natural numbers below the square root, right? What I'm trying to say is the numbers would be something like root 2, root 3, root 5. These are the commonly seen ones, or something like root 8, uh, root 8, root 9, root 7. Not frequently asked, but these kind of numbers. You're getting my point, right? No decimals. These would be asked for number line part. Whereas in this part, in geometric representation, you will get numbers which have decimal parts to it, like 9.3, 3.6, root over of such things. Right? For that, you need to do this method. This method is relatively simple and relatively clean. Okay, so what you need to do is use your scale and draw a line measuring 9.3 centimeters. Let me just use another color. Okay, so I'm going to draw a line. Let's call this OA. Okay, and this should be 9.3 centimeters. Okay, once you're done with that, at A, draw another line called B, which is just 1 centimeter. Done? Tell me when you all are done, then we'll go ahead.
I'm done.
Done?
I'm making
Others?
1 second.
Okay.
Ma'am, done.
Okay, what about the others? Waiting for you.
Ma'am, I'm done too.
Okay.
Yes, ma'am, done.
Done? Everybody done? Okay. Now what you do is you need to find the midpoint of this line OB. I'm writing it here, okay? Midpoint. Be very careful. This is the step you will go wrong. Midpoint of OB, okay? Which is nothing but 9.3 plus 1. Iska midpoint you have to find, which is 9.4, right? So you either you use your divide by 2 if you're good at
Ma'am,
it,
it's
or just
10.4, right?
using your, yeah, sorry, I'm so sorry, I'm not reading it properly. Yeah, it would be 10.3, right? Correct, thank you. Okay, so now you can just use your scale. So this would be nothing but 5 point something, 5.6, I guess, right? Okay, so you need to take the midpoint of this. This is the only part which will involve little amount of calculation. Again, if you're good at it, you can just observe with your scale and mark it. If you're not, you can divide by 2 quickly and get the midpoint, right? So that would be, let's call it x. Let's not confuse the terms. So 10.3, which would be nothing but 10.3 by 2, right? So midpoint of this would be something around,
5.15.
okay, 5.1.
5.15.
Yeah, so if you are not able to mark 1.5, make it 5.2 and mark it there. Mark 5.2 here as x, right? This is x. Okay, done? Everybody done till here?
Ma'am, done.
Done?
Yes, ma'am.
Okay, now take your
Yes, ma'am.
compass. Take your compass and
Yes,
take your
ma'am.
radius as OX, which is nothing but 5.2.
Ma'am, it's
Radius,
5.15.
okay, 5.15. Are you able to take 5.15 using the scale though? I mean,
I did it somehow.
okay. Yeah, that is why I was like, round it off. It doesn't matter, right? Make it one decimal place. Okay, whatever. If you are able to take 1.5, okay. If not, 5.2, right? Radius as OX. So just take
Yes,
OX.
ma'am, done, ma'am. I took it.
OX. Awesome. So keep it at O and draw an arc. Wait. Keep it at X and draw an arc. I'm so sorry. So basically, you'll just be connecting these two, right? Okay. Something like this.
Ma'am, from the middle point, right? Like the
Yes, from
center.
X, yes.
Yes, ma'am, done.
Done?
Done, ma'am.
Done. What about the others? Y'all are very quiet. Where are y'all?
Yes, ma'am,
Yes,
done.
ma'am, done.
Done,
I'm done.
done. Okay, very good. Good. Now what you need to do is use your scale and join A to this arc, to this semicircle. I'm drawing it in pink. This is your
Ma'am, can
construction.
you repeat? I
Yes.
didn't hear.
Use your scale and join this point A where that 9.3 centimeter ended, right? Join that point to this arc of this semicircle.
Done, ma'am.
Done. Let me call this D. Now take AD as your radius. AD as radius. Second radius is AD.
Yes, ma'am.
Place it at A and draw an arc. So you'll get somewhere some line like this here. Okay. So if you draw an arc, you'll get an arc here like this.
Yes, ma'am. Done.
Done. Okay, done. We are done with our question also then. So this distance
Ma'am, what
which
is
is
the radius? Ma'am, AD,
AD.
right?
AD, yes, AD.
Okay.
So this distance which is nothing but, let me call this AP. Okay, AP is what is your root 9.3 units. Got it? Okay, I will repeat once you're
Done.
done. Tell me, I'll repeat the steps in case you want to write it down somewhere.
Ma'am,
How
done.
we did it.
No, ma'am. Ma'am,
No?
it's okay.
Okay. ठीक है. Okay, so first thing you do is you whatever value is given to you, you draw a line, okay, measuring that distance. Suppose I give you root 4.5, ठीक है. So you take 4.5 units on your scale, you draw a line, ठीक है. Then next to it you draw 1 centimeter, okay, and then for that complete line segment, which is nothing but 4.5 plus 1, which would be 5.5, right? So 5.5, you find the midpoint of that, and then you draw a semicircle, and then you join this point where that first line ended, okay, to the arc of the semicircle. And then take that as the radius and draw your final arc again back on the line, on the baseline, and that distance between this point to this point is what is your under root of that value. Okay. Okay. So this is called
Yes, ma'am. It's
geometric
easy.
interpretation, and yeah, this is how you do it.
Ma'am, geometric representation, right?
Geometric representation.
Yes, ma'am. So
Done?
we are done, right?
Yes, we are done. We are done. Yes, I remember we have to play. Don't worry. I won't extend the class.
No, no, ma'am. Just like I was asking of, like all we are done, like with
Yeah, yeah,
today's
we are done. We are done.
all study. Yeah,
But I will give you homework. So you will have to
yeah.
do that. Okay. Okay, what about the others? Done?
No
Done?
problem with the
Chalo.
homework.
Yes, ma'am.
Yes, ma'am.
Good, good. ठीक है, yeah, I won't give you too many, just whatever we did today, na, one or two questions on each of that, so that if you do it today itself, it will be crystal clear that you understood the concept and you've practiced also, so then there won't be any issue. Okay,
Yes, ma'am.
ठीक है, चलो, let us play your game. Let me
Yeah,
okay.
ma'am. Just you can present.
Yeah, yeah, I
Shall
had to
we?
remove the whiteboard, right? So because of that.
Yeah, yeah. So like, but ma'am, while writing the words, don't present, or it would be like,
Okay.
yeah.
Ma'am, like when it's your chance, don't like stop presenting.
Okay, okay, let me just.
Actually, stop presenting while while we are playing.
So
Yeah,
while
we play.
entering the names too.
Yeah, actually. So, ma'am, you have to
I
create a
would
private
do.
room. Yeah.
Okay.
Ma'am, you didn't write your name.
Oh, I have to write my name also. Okay.
Yes, ma'am. Either like if you
Yes,
don't
ma'am.
write your name, it will give you a random name, and those are like
Yeah.
really
Those are like sometimes they are very weird.
Okay, what should I put my name as? Some. Okay, I put it D.
Yes, ma'am.
Okay, private room. This is like Kahoot. Have you all played Kahoot?
Yes, ma'am.
No,
Yes,
ma'am, I
ma'am.
haven't played.
Yes, ma'am.
This is Kahoot is a
When you
better
have to create
version. Yeah.
private room.
I pressed that only. It took me to some ad.
Ma'am, then like just like do it again. Go back and do it again. Then the ad won't come. Oh, it went.
Okay.
Yes, ma'am. Like now the like use custom
Ma'am,
words
wait.
exclusively.
Ma'am, wait, don't
Send us
type
the
the words
link.
now.
Haha, I'm not
Yeah.
typing. Don't worry, don't worry. How many rounds do I need to give? Three? Is
Ma'am,
sufficient?
Ma'am,
like it
Ma'am,
is
how much
only
is it?
one.
anything.
Ma'am, two or three. Ma'am, because I have
Let it be
some meeting.
3.
Okay,
Okay,
Aryan
okay.
Yes,
has to go.
Ma'am,
Yeah,
3 is
three
okay.
is
Okay,
fine.
okay. 80
Ma'am,
seconds.
it's okay, ma'am. I'll play one round.
ma'am, you have to click on that use custom words exclusively box.
Yes, ma'am.
Okay, use
For
custom
adding
words.
Ma'am,
your
first,
own
ma'am,
words.
send us the link.
Ma'am,
Where is
like
the
send it on
link?
the group.
Meet.
Ma'am,
Acha, okay,
like
okay.
at the
Got it,
bottom
got
of
it.
the
Yep, got it. Chat. Send it to all, everyone in the meeting. Send. Yeah, I've sent it. You can
Ma'am, you
join
can
by
now type
then.
the words.
Yes, let
The
me do
words you
that.
want.
Yeah,
Yeah.
very easy. I don't know. I mean, okay, but take it. Chalo. Whatever we did today, I'm just adding those words. I'm giving you hint also. Okay, three are here. Somebody, Sam, Suhani and Aryan. Oh, Samruddhi. Samruddhi gave me a Sam. Okay.
Yes, ma'am, that's my short name.
Okay, nice. Just give me 1 second. I'm typing like so slow. Uh,
Ma'am, 1 second, I'm joining.
okay.
Ma'am, we could like first play a normal game, like so you get like how it works and all. Because then if we directly start with like that's what Sir
Yeah.
did yesterday.
So like start with normal words like umbrella, smiley face, all that.
No, it's okay. I just added some math word there. Anyway, they are very easy. But okay, let us do that. Am I
Okay, ma'am.
missing something? Okay, yeah, this is sufficient. Let us play that. Okay, start. Everybody's here.
No, ma'am, I'm
Yes,
not
ma'am.
yet there. Just
Okay.
a second.
Yeah,
Yes,
you're
ma'am,
Yes,
there
I'm
ma'am,
now.
he joined.
Okay, I don't need to present my screen, is it?
Yeah, don't present your screen.
Don't
No,
present.
ma'am. You don't need to.
Okay. Sujal is drawing. Nice. Okay. Okay. Interesting. Now I'm confused. What is this? Uh, okay. Why is it not taking up this person's guess?
Ma'am, like it is wrong. That's why it won't
Yes,
take up.
ma'am.
Oh, okay.
It's not the exact word.
He's just like
Oh, like that.
missing one letter.
Acha. Good, nice. When you wrote whole, I got confused. Till then, even I was like, good, doing good. But you wrote whole, then I was like, what
Yes,
is
ma'am.
it?
Like I wrote the wrong spelling, like because then if you would I would have written the correct spelling, then everyone would have guessed it.
Yeah, yeah, yeah. Okay, try. Don't write stuff. Okay, don't write the words there. Just draw. Just use numbers. The fun would be lost otherwise. Okay. Hmm. Hmm.
He's just
Try
drawing
again,
random
try
stuff
again.
now.
Give more examples, no? Suhani guessed it. Okay. Who is it trying to? Who is this trying to draw? Just use more
Ma'am, me.
examples.
It's me.
More examples.
Wait, yeah.
Don't write the same thing again. Maybe they're not understanding what you're trying to say. Huh. You should have used two, three
It was
examples.
so
They would have got
simple.
it then. Okay. Not to worry.
Ma'am, you have given very easy words.
Yeah, I did. I gave you a hint also that whatever we did in this class, only that.
Excuse me, ma'am.
Just tell me.
Ma'am, I have to go somewhere, so can I leave the meeting?
Yes, sure. We are done for the day. I will post the homework on the group. Don't worry. Okay. Bye. Sad. Aryan gave all examples.
Ma'am, he just like did not write S, or he would have got it way earlier.
Oh wow, I got kicked out. Okay.
Oh, ma'am, you can join in back again.
Yes, ma'am. Rejoin through the link.
Ma'am, did you like add only 4 or 5 words?
I know there were some 6, 7.
Ma'am, so they'll keep repeating again and again.
Oh, is it? No, there were
Yes,
some
ma'am.
sufficient ones, though it did not ask you multiple ones. Okay.
Ma'am,
Continue.
because one of them just got repeated.
Ah, yeah, I'm not familiar. I might take one or two trials to get familiar with this. So hopefully I won't get kicked out now. Try again, try again. She's who is this guessing? Yeah, she's given good examples. You're missing the main thing she's drawn there. Yeah.
Ma'am, I wrote the same thing, but still I got knocked off. The
Me
meeting is
too. It's
closed.
literally not the same thing.
Aryan, spelling. Your spellings are
The hyphen in between.
Or
just
either the hyphen.
Oh, okay. I did not put like the hyphen in between.
okay. I got a
You have
word.
to choose a word.
Okay, okay. This is very easy. Okay, let us hype up everybody's points. Come on, fast. This is very easy. That's it. Aryan, how how is it root for?
Who is Discord, by the way?
Yeah, who is this called? Okay. Number line. Who is Discord? Is it somebody from somebody from outside or is it
No,
our
ma'am.
people only?
People from outside can't join like in the game until you give them the link.
Okay. Uh, who is Discord? That person is not answering also. Strange. Okay, never mind. Oh, the same word got repeated, is it?
No, ma'am, it is different.
Acha.
Ma'am, I get it. I guess Discord is Swayam because he left from the other one.
Ah,
No, but
maybe.
Discord entered even before Swayam left.
Yes, so like he might have joined from both of
Yeah, it could be possible. He has some connection issues also. Yeah. Like somebody else also came. I don't know who are these people joining in. I got
Ma'am, it says I
disconnected.
got disconnected.
Mama, it's
Hilarious.
me.
Okay, it's you.
Mama, I got, yeah. I just took a random name.
Okay, so Discord is also you, is it?
No, ma'am, Discord isn't me.
Oh, ठीक है, God knows what it is. Oh, you get a hint up here also. I did not know that. Wow. They're up.
Yes, ma'am, like you get
They
a
tell
word
you.
or something.
Yeah, they're telling you what is the. ठीक है. हाँ. Close, close. Sujal, look at the word and now you guess again. Sujal, I'm giving you hints.
Okay, ma'am.
So one is also correct. Yeah. Why is it not accepting though? I don't know what I gave also.
It was irrational numbers.
Hey, who is the person who did this? Wait. Who did this?
Ma'am, I did this.
This is wrong, dear. How will you put 1.3 recurring as
Uh,
irrational? Irrational are non-recurring,
uh,
non-terminating, right?
yeah.
That became an error. Okay, ठीक है. Not to worry. Continue. Again, Ashka, check your hyphen. I mean, check. Yeah, hyphen is missing. That's all. It's correct. Okay.
Ma'am, I was typing and it got over.
Okay, should we
Yes, ma'am.
continue
So
or should we end?
Ma'am, we can end because same words are repeating.
yes,
Same
ma'am.
words are repeating. Right.
Ma'am, can I leave because I have a meeting now?
Yes, Arya.
Yes, ma'am, even I have a
Like,
meeting. I'll have to
Sure,
leave.
sure. Okay, let us end our class.
Yes, ma'am. Bye,
I
ma'am.
will give you
Bye,
homework
ma'am.
on the group. Bye. See
bye,
you.
Bye,
ma'am. Thank
ma'am. Thank you.
Bye, ma'am. Thank you, ma'am.
Bye,
Bye.
ma'am. Thank you, ma'am.